Deep learning is a powerful type of artificial intelligence that has revolutionized the way we interact with technology. It allows machines to learn from vast amounts of data, enabling them to perform tasks that were once thought to be exclusive to humans. Imagine a child learning to identify objects. They start with basic shapes and colors, gradually understanding more complex concepts. At first, they need simple instructions and guidance. Deep learning operates in a similar manner, starting with basic data and progressively learning more intricate patterns. It uses artificial neural networks, which are designed to mimic the human brain, to analyze data and make predictions with remarkable accuracy. This technology is changing the world around us, integrating into various aspects of our daily lives and industries. From self-driving cars that navigate our streets to advanced medical diagnoses and robotic surgeries, deep learning is making its mark and pushing the boundaries of what is possible. Neural networks are the backbone of deep learning. They are inspired by the human brain. Imagine a network of interconnected neurons. Each connection carries information. In artificial neural networks, these connections have weights. These weights determine the importance of information as it flows through the network. During training, the network adjusts these weights. It learns to identify patterns and make accurate predictions. Traditional neural networks struggled with long sequences of data like sentences. Then came transformers. Transformers excel at processing sequential data. They use a mechanism called attention. Imagine reading a sentence. You naturally pay attention to certain words to understand the meaning. Attention in transformers works similarly. It allows the model to focus on important parts of the input sequence. Section 4. Attention is all you need. Understanding the core of transformers. Attention is a game changer in the world of neural networks. It allows models to focus on the most relevant parts of the input data, making them more effective and efficient. It allows transformers to process information in parallel, which significantly speeds up computation and improves performance. This makes them incredibly efficient as they can handle large amounts of data quickly and accurately. There are different types of attention mechanisms, each serving a unique purpose in processing information. Self-attention helps the model understand relationships within a single sequence, allowing it to capture dependencies and context effectively. Multi-head attention allows the model to focus on different aspects of the input simultaneously, enhancing its ability to understand complex data. The transformer architecture is built upon these attention mechanisms, making it a powerful tool for various applications in natural language processing and beyond. Section 5. Conclusion. Transformers and the future of deep learning. Transformers have revolutionized deep learning. These models, with their unique architecture, have enabled machines to understand and generate human language with unprecedented accuracy. Their ability to handle sequential data has led to breakthroughs in natural language processing. This has opened doors to more sophisticated applications and improved performance in various tasks. We see their impact in language translation, text summarization, and even code generation. These advancements are transforming how we interact with technology on a daily basis. As we continue to explore the potential of transformers, one thing is clear: they are shaping the future of artificial intelligence. The possibilities are endless and the journey has just begun.